All right, welcome back. And today we're going to do a question called jump to the end. Let's get right into it. So starting at index 0, for an element n at index I, you are allowed to jump at most n index ahead. Give a list of numbers. Find a minimum of jumps to reach the end of the list. Okay, cool. So this is a classic question where it's a little bit like the rabbit that depending on where you land, you could jump however far you can depending on the value. Like for example, if we land here, we could jump 3 spaces. We could jump all the way to 2, all the way to 5, or all the way to 1, right? And then what we want to know is what's the minimum amount of jump you can get to the end of the list, which is this one right here. So we imagine if we think of brute force. Actually, this is a good way of talking about it. Like if it's brute force and you say, okay, I want to go 3 steps, 1, 2, 3, but then now you can only go 1 step, so you go 1, and then now you can only go 1 step, you go 1. Now you see a 9, so you could go as many steps as you want, or maximum 9, and then you go all the way there. So that took you like 4 jumps. But the actual answer is to jump to 5 so that you could jump to 4 directly. So that would be 2 jumps, right? Which is much better. So this is kind of like the coin change problem almost. So as you can see, this is actually a dynamic programming question. And so we're just going to do it. And then because it's a dynamic programming question, it should be pretty obvious to you how to do this. But okay, so let's jump right into it. So let's draw our input array first. So our input array, let's see what it was. It was 3, 2, 5, 1, 1, 9, 3, 4. So this was our input array. Okay. So then the key here is to have an array to remember what's the minimum jump to get to a certain place. So let's call this jumps. Okay. And then kind of like think of this as like a dynamic programming question. So here, what we're going to remember is we're going to remember what's the minimum amount of jump to get to this specific place, right? So think of this as like the same arrays, right? So first we'll initialize it all to like infinity, or like a number that's really big, because we want to know the minimum amount of jumps. So we're going to update it every time. Here we can start with 0 because that's where we start anyway, so you don't need to jump to get to here. And then here it's all infinity, right? Let's just say it's infinity. All right, and then now we're gonna actually do the work. So how are you gonna do the work? So first, if we see the number 3 here, okay, then you know that you can get to here, here, and here in one shot. How do you know this? Because here you already jumped 0 times, and then what's 0 plus 1? It's 1. So you know you can get to here, here, and here with 1 jump. So is 1 smaller than infinity? Yes, it is. So now this is no longer infinity. It's 1. Now that we're done this is still 0, by the way. This is 0, so 1, 1. So now we're at number 2 now. So then 2, we could jump 1, 2 spots. So we know that we can get to this spot and this spot with another jump. Currently, we already have 1 jump, so we add 1 to that. So we know we can jump to this position or this position with 2 jumps. But is 2 smaller than 1? No, it's not. So it doesn't really matter, so I'm not going to update that. So now we're done with that. Now we're at 5. We know we could jump to 1, 2, 3, 4, 5. All these numbers, we could jump to all these guys in 2 steps because I am currently 1, and then I just need to add 1 more step. So now I know that I could get to here in 2 steps, but 2 steps is bigger than 1, so I don't really care. 2 is bigger than infinity, so this becomes 2, this becomes 2, this becomes 2, this becomes 2. And then we continue and we do the same thing. I'll go a little bit faster now. So 1, I know I could get here by 1, doesn't change anything. 1, I could get here by 1. 3, it doesn't change anything. 9, I could get here by 3, it doesn't really change anything. It's kind of obvious. Once you reach the end, it's you're pretty much you're almost pretty much done. But there are some cases where you will not be done. Like for example, if this guy was like 1, imagine if I had an input array like this, 1, and then like maybe 5, and then we have, let's see, 1, 2, 3, 1, 2, 3, 4, 5, 6. Imagine I had 6, and then 6, 6, 6, 6, 6, right? So, or like maybe this is like 4. So then you would think that like once you reach 5, because you could reach 5 once you get here, because you add 6 and you don't even need 6 to get to 5. But then this guy will actually be 3. But then once you get here, 1 plus 1 equals 2. Basically what I'm trying to say is that you need to go through the whole array to actually know what's the final number, because sometimes your value can be higher and then you could replace it by something that's smaller. Anyways. Okay, cool. So yeah, so that's pretty much it. So after you finish iterating through the array of input, and then also you have completed all your jumps array, then all you have to do is read the last element, the value. And here it's 2, so your output would be 2 jumps. That's the minimum. Now, what's the time complexity of this? So the time complexity of this would be O of n squared. And the reason why is because you have to go through the input, and that's O of n. And then for each value, you remember that maximum, you have to update all of these guys. You know, like for example, when we saw 5, we had to update this guy, this guy, this guy, this guy, this guy, or you have to iterate through them. So that's another O of n. And then, so yeah, so it's kind of like a loop within a loop. So O of n times O of n equals O of n squared, right? So what about space? So the space complexity, we added this array, right? And then the jumps array, that's O of n. Cool. So that's pretty much it. So yeah, let's code it. So first we want to create our jump array. All right. And then we want to initialize to the biggest thing possible for every one of these, for every one of the values in the beginning. And then, yeah, so that's how we initialize the array. Let's set the beginning to 0 because we don't need to jump anywhere to start. And then we wrote our first loop, which we care about the index, and we also care about the value of the numbers, which tells us how many squares we can jump. Okay, and then for each of these, we're gonna loop through the whole jump array. So for j in range 1 to like n plus 1, what we're gonna do is we're gonna make sure that it's within range. So we're gonna make sure that it's smaller than number, because or else it'll break. You know, so if not, we'll just break it. And then, so if it is, then remember what we did. What we cared about is we want to update the jump array. We add the number of jumps onto ourselves, and then we take the minimum of what is already there, which is this one. Oops, 1 plus j. Yeah, so we take the minimum of what's already there versus ourselves plus 1. And then that's pretty much it. And then once you finish iterating through that, you just return the last element of your jump array. And then that's pretty much it. So let's see if this works. All right, yeah, it gives 2 indeed, so that's great. Yeah, so let's think of another example. Imagine if this was like 111, it should only take 1 jump. Excellent. And then, yeah, so that's pretty much it. I hope you enjoyed that, and thanks for watching. See ya.